All right, hello. This video is going to focus on topic 1.7, summary statistics for a quantitative variable. There's three learning objectives. However, we're only going to focus on the first one here, which is to calculate measures of center and position for quantitative data. You might recall that in the last video, we eyeballed the center, right? We looked at a histogram and just kind of look to see where the peak was located. And in this video, we're going to actually calculate the center a few different ways. All right. So before we jump into these calculations, let's talk about the word statistic. So statistics, plural, is the name of the course, right? It's the study of data and the variability in data. But the word statistic, singular, is a number that describes a sample. So in this diagram, we have kind of an outline of the state of Massachusetts and all these little silhouettes of people, right? That's supposed to represent every adult or every person who lives in that state. And if we could measure the blood pressure of every single person in the state of Massachusetts, we would arrive at this number here, 78 millimeters of mercury. However, that's kind of not realistic, right? Even a state as small as Massachusetts has a lot of people, and it would be very difficult to measure every person's blood pressure. So a more realistic scenario is to gather a sample of people from Massachusetts and to measure their blood pressure and find the mean. So of all the numbers here on the screen, the three on the bottom are statistics, right? These are numbers that describe a sample of people. And then the number here on the top is not a statistic, right? That number describes a population, and it has a different name, but numbers that describe samples are called statistics. All right, so I'm gonna switch over here to the document camera because I wanna work with paper and pencil and show you how to calculate things like the mean and the median, quartiles and percentiles, right? These are all ways of measuring either the center of a distribution or like positions within a distribution. Okay. So let's start with this data set that I created. And I just tried to keep this simple, so they're all single digit numbers. It's not an extremely large data set. I believe it has 15 values in it. And so we'll start with the mean. The mean is your basic average. Okay. So we use the symbol X bar to represent the mean, and it's going to be the sum of the individual values divided by the sample size. Okay. All right. So we're going to start adding these up. 1 plus 1 plus so on, all the way up to 9. And then divide by the number of values we have, which is 15. Okay, earlier I added these values up and I got 58. And so 58 divided by 15, I'm going to approximate this to 2 decimal places. It would be 3.87. Okay. All right. So that's your mean. Sometimes the mean is referred to as the fair share value. So if you were to take the sum of all the data and divide it equally among the number of items you have, this is how much value each item would be worth. All right, so another way of calculating the center is the median. Okay. So the median is just going to look for the middle value in the data set. So because I know there's 15 values in this list, if I were to divide that into 2 equal groups, like it would have 7 values in a low group and 7 values in a high group. All right, let me use a highlighter to demonstrate. So 1, 2, 3, 4, 5, 6, 7, that's my low group. 1, 2, 3, 4, 5, 6, 7, that's my high group. Okay, and so there's one number left out, okay, and that number is the median. We use a capital M for the median. So the median equals 3. Okay. So it's literally the value in the middle of a distribution. Of course, the distribution has to be in order first from least to greatest. All right. So you might be wondering, well, what if the sample size was even, right? What would you do in a case like that? And so I have this one over here, which I believe has 12 values. So in this case, 12 values, if I divide that equally, I have 6 values in the low group and 6 values in the high group. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So the median, in this case, is going to be the average of the 2 values here in this middle position. All right, so in this case, the median is going to be the average of 3 and 3. Okay, so not a very interesting scenario, but 6 divided by 2 is 3. Okay. So if you are ever in a situation where you have an even amount of numbers and you're trying to find the median, you will just average the 2 numbers in the middle as opposed to just taking the 1 value in the middle. All right. So the median is the value such that 50% of the distribution is below that value. You could also say 50% of the distribution is above that value, but we normally talk about the percent below. So the median is the value such that 50% of the distribution is below it. We could also find other locations in the distribution, but not 50%. So like we can find a value so that 25% of the data is below it or 75%, and we call those the quartiles. So if the median divides the entire data set in half, finding the quartiles will divide these 2 subgroups in half. So if I look at the group of low values, I'm going to split that in half again. So I'm going to have 3 values, and 1 left over. Okay, and so that number is the first quartile position, right? So we call it Q1 and its value is equal to 1. And then if I go to the group of high values and split that in half, right, we'd have 3 highs, 3 lows, and then so the number left over here would be 7. This would be called the third quartile. Right, so the first quartile is 1/4 of the way through the distribution. The median is 2/4 or halfway through the distribution. The third quartile is 3/4 of the way, through the distribution. This is sometimes referred to as the 25th percentile, the 50th percentile, and the 75th percentile because it describes how much data is at or below that position. Okay, so 75% of the data is at or below 7. All right, so what about when we're in that situation of having an even group of numbers? Well, so if I wanted to find the quartiles here, right, I know I have 6 values in the lower group, so I'm going to do 3 and 3, 3 and 3. Okay. And so I don't have 1 number left over in the middle, but I do have these 2 numbers that were in the middle, and I'll average them. So the first quartile would be the average of 1 and 2. So 3 divided by 2, 1.5. Okay. And we can do the same thing with the group of high values. We can divide it in half. So we have 3 and 3. And so our third quartile is going to be the average of 5 and 8. All right, so 5 plus 8 is 13. 13 divided by 2 is 6.5. Okay, so we've talked about 2 ways of measuring the center. The mean, which is just a basic average. The median, which finds the value in the exact middle of an ordered list. And we've talked about how to find some measures of location. So the 50th percentile, the 25th percentile, the 75th percentile, or these quartiles. But we could find other positions, right? Like I might want to know, you know, where does, say, a value of 5 in this distribution rank compared to a value of 5 in this distribution, right? So let me go ahead and copy these down again, and then I'll show you how we can compare them. 1, 1, 1, 1, 2, 2, 2, 3, 4, 5, 6, 7, 7, 7, 9. And then we have 0, 1, 1, 2, 3, 3, 3, 5, 5, 8, 9, 9. All right. So what if we wanted to focus on the value 5? We can describe the position of the value 5 by writing out the percent of the data equal to or less than. Okay. So the place where 5 ranks in this distribution, well, it's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. It's the 10th value in a list of 15, right? And so that's 0.67 for the 67th percentile. Okay, so that's where it would rank at, right? The 0th percentile would be rank at the very low end of the data set. The 100th percentile would rank at the high end of the data set. So 67th percent means that we're past the median, we're past the halfway point. Okay. All right, how about in this data set, right? Where would a value 5 rank here? Well, there's 2 5s, so we'll just look at all of them plus everything less than it. Okay. So the last 5 here is at the 1, 2, 3, 4, 5, 6, 7, 8, 9th position in a list of 12. Okay, and that's 0.75, which would be the 75th percentile. Okay. So we can say that a value of 5 ranks at the 67th percentile in the first data set, but would rank at the 75th percentile in the second data set. So 5 is a much higher value in this data set than it is in this data set.